In this video, we're going to show that two vectors are collinear. And I want you to try the question first, pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So here we've got a regular hexagon, A, B, C, D, E, F, with center O. Express in terms of A and B, the vector AB and the vector EF. So remember, we always state that vectors must have the same direction and magnitude. So what I'm going to do here is say, well, let's just write, if OB is 6B, let's just write EO. So let's write in the vector E to O. And that is in the same direction as OB, which is 6B. Now, we can also say that O to A is 6A, so therefore C to B is also 6A. And that X is the midpoint of BC, so meaning that CX is 3A and XB is also 3A. So we've got that written down. Then they also say we need to work out what the vector AB is. So, well, AB is going to be AO plus the vector OB. So AO is minus 6A because it's the opposite direction, and OB is 6B. So we've got AB written down as minus 6A plus 6B. Now EF, we can say, is exactly the same direction as OA. So if OA is positive 6A, EF is exactly the same because it's the same direction. So we can say EF is going to be 6A. Then it says X is the midpoint of BC, which we've done that and we've marked in the corresponding vectors. We want to express EX in terms of A and B. So I'm going to draw that line in. So EX. So that's the vector that we want. So we can say that the vector EX is going to be EB plus BX. So it's EB plus the vector BX. Now, EB is going to be 6B plus 6B, which is 12B. So we get 12B there. And now if XB is positive 3A, BX is the opposite direction. So we get minus 3A. So we now know what the vector EX is. Then the question continues and states that Y is the point on AB, which is extended, such that AB to BY is 3 is to 2. So let's write that in. So AB is 3 shares, BY is 2 shares. So I'm going to extend the line slightly here. So make it, put Y, say here. So we know that they've told us that AB was, let's go back to the question, AB was 3 shares, BY was 2 shares. So that's going to be 3 out of 5 and 2 out of 5. But the problem here is we don't know what the entire line AY is, but we do know the vector AB. So what I'm going to do is do the following. I'm going to say, well, AB is 3 shares. So we've got AB to BY, they told us was 3 to 2 in terms of shares. So I'm going to write 3 shares is what AB is. I'm going to write down what AB is in terms of shares. So AB is 3 shares. So we get 3 shares is the same as minus 6A plus 6B. Now from there we can work out 1 share. 1 share is going to be dividing everything by 3. So we get minus 2A plus 2B. So now we can work out 1 share, which is minus 2A plus 2B. Then BY is 2 shares. So we're going to double all of this. So we get minus 4a plus 4b. So we now know what the vectors AB is, and we know what the vector BY is. Now, if EXY is a straight line, I want to show that EY is a multiple of the smaller vector EX. Because EX and EY are collinear, they lie in the same straight line. So we found out what EX is. We need to work out what EY is. So I'm going to say, right, well, EY is going to be the vector EB plus BY. So it's EB plus the vector BY. Now, we know what EB is. We said that EB was 12b. So we've got 12b. Then I'm going to write BY in, which is minus 4a plus 4b in red. So then we can simplify this. So collecting the like terms, 12b plus 4b minus 4a. So that's going to give me 12b plus 4b is 16b minus 4a, which is the vector EY. Now, we want to show that EY and EX lie in the same straight line, i.e. that they are collinear. And what that basically means, we've got to show that one vector is a multiple of the other vector. So the way we're going to do that is, I'm going to say, right, let's write down the vector of EX. So EX is 12b minus 3a. Now, we've come across a problem like this before. It doesn't look anything like it at the moment, but what I'm going to do is divide everything by 3, so doing a third of EX, and let's see what happens. A third of EX will give me 4b minus a. Now, if I notice, I'm going to write EY here in green, which is 16b minus 4a. Now, I can tell that's 4 times what a third of EX is. So I'm going to write that down. So I'm going to say, well, 4 times a third of EX will give me 16b minus 4a, which is exactly the same as the vector EY. So now we have a relationship. So we can say, so now we have a relationship, and the question says prove that EX and Y lie in the same straight line, that they're collinear. So we can say, right, first point, EY is a multiple of the vector EX. EY and the vector EX are parallel vectors, Remember, we said that if 2 vectors are parallel, one is a multiple of the other. So we can also say that EX and EY emanate from the same point. They have a common point E. So EY and EX emanate from the same point. They have a common point E. So we can say, so now we can say that E, X, and Y lie on the same straight line. Remember, the mathematical word for that is that they are collinear vectors. Okay, that's it.